This video is on calculating the hydroxide and hydrogen ion concentration from pH. So in a previous lesson, we learned how to use these formulas to calculate pH from our hydrogen ion concentration, which was just a one-step sort of problem, taking the negative log of that hydrogen ion concentration. We also learned how to calculate pH if we're given the hydroxide ion concentration. In that case, it was a two-step problem where we first had to take the negative log of the hydroxide to get our pOH, and then pH and pOH are related by the number 14, so we could figure out our pH from that. So in looking at a problem similar to this, if I had a hydrogen ion concentration of 1 times 10 to the negative 3 molarity, as long as this number is 1, what we can do is say that the pH is the power of the hydrogen ions. So in this case, the power is 3, so the pH is 3 for this particular solution. Now, if we wanted to, let's say we had the pH and wanted to go back to the hydrogen ion concentration, as long as the pH is a whole number, so no decimal places or anything like that, then we can do the reverse of this without even getting a calculator involved. So the power of the hydrogen ions is 3, and so my hydrogen ion concentration would be 1 times 10 to the negative 3. But if my pH has decimals, then what I'm going to need to do is I'm going to have to plug it into this formula and rearrange it. Well, rearranging an equation with a log, it takes a little bit more of a difficulty level. So the state has actually giving you these equations rearranged already on your reference tables. So I'll show you where those are. So here's our formula for pH, and they rearranged it, and it looks like this. Same thing for pOH, and when they rearrange it, it looks like this. So you have these equations already rearranged. You just have to use the appropriate one. If you're looking for pH, you're going to use one of these two formulas, depending on what you're given. And if you're looking for concentration, then you're going to use one of these two formulas, again, depending on what you are given. Okay, so let's look at a problem here. Oh, that was the one we just did. So let's look at another one. Okay, so if we have a hydroxide ion concentration of 3. All right, so with that one, we know that the pH is the power of the hydrogen ions. The pOH is the power of the hydroxide ions. So if I'm given the pH, I can find my pOH by subtracting it from 14. So this would be 14 minus 3, which would end up being 11 as my pOH. Now, that is the power of my hydroxide ion concentration. And so my hydroxide ion concentration, and again, this is a whole number here, so I can say is 1 times 10 to the negative 11 molar. All right. Again, if we have whole numbers for our pH, we can do this very, very easily just by knowing what pH and pOH are. Otherwise, we have to use these formulas. And again, these formulas that I have here in bold are all given to you on your formula tables or your reference tables. All right, so now let's use those, and I'll show you how. Okay, so first let me show you that 10 on different calculators. On this type of calculator, it is second log, and you can see that 10x right there. That will put, if I have that on here, it puts 10 up caret. And so then I could just plug in my negative pH. On the larger calculators, your log button is here. And again, it's the second function of that log. And then you can put in your negative pH. All right, so let's work a problem with those. Here we go. Let's look at that first one. So we want to know what the hydrogen ion concentration is. and they give us a pH of 5.91. So to plug that in to the formula, we're going to use this formula right here because I am looking for my hydrogen ion concentration. All right, so that's 10 to the negative pH. Make sure when you're plugging this into your calculator, you do put in that negative sign. If you don't, you will get an answer, but it will not be the correct one. All right, so 10 to the negative 5.91 is what I'm going to plug into my calculator. All right, so I've got, start over, second log, and that gives me 10 up caret, and then it's going to be negative 5.91. And I'll end my parentheses there, and I get a long number in scientific notation. Now I can count and move how many times I had to move the decimal to get it in scientific notation, or I can change it into scientific notation using my calculator here, go over to psi, and that's going to give me 1.2 times 10 to the negative 6 molar. If it's square brackets, the units are molarity. And so that would be my answer there. All right, so now let's look at the other one. If we have a hydroxide ion concentration. All right, so we're looking for the hydroxide ion concentration, and we have a pH of 9.2. Well, the formula that allows us to find our hydroxide ion concentration is right here, and it says that it's going to be 10 to the negative POH. Well, I don't have POH, I have pH. So I need to calculate my POH, which is easy because they're related by the number 14. 14 minus pH is my POH. So 14 minus 9.2 will give me my POH. So 14 minus 9.2, and I get 4.8. So now that's my POH, and that needs to go in here. 10 to the negative 4.8. And so what I'm going to do is second log negative 4.8. And it's 1.5, so I'm going to say that this is 2 times 10 to the negative 5. And again, it's square brackets, so that means molarity, and that would be the correct answer for this one.